Construction of triangles.
Construction of triangles. 3 sides given. The elements of a triangle. Before we start with the construction of triangles, there are few important things we need to know. The 3 sides and 3 angles of a triangle are the elements of the triangle. If all the 6 elements are given, it is easy to draw the triangle. However, a triangle can be drawn even when only a few of the elements are known. Remember to always draw a rough diagram before you do the actual construction of a triangle. A rough diagram makes it easier to construct the required triangle according to the given measures.
Given the measures of the angles and sides of a triangle, let us find if we can draw a triangle of these given measures. Draw triangle PQR such that PQ is 3 cm and QR is 5 cm. Come on, let us try drawing this triangle. First, we will draw a rough figure. Draw segment QR as shown here. Then draw segment PQ. Now segment PR. Triangle PQR is as shown here. But we can take point P here and draw triangle PQR, and then it will be as shown here. Thus, we can draw several triangles satisfying the given 2 conditions. And so, if we want to draw a unique triangle satisfying the given conditions, then the 3rd condition is also required. Hence, for constructing a triangle, we must know minimum 3 elements. Let us now construct few triangles.
Construction of triangles. 3 sides given. Let's construct a triangle when the lengths of all 3 sides of the triangle are given. Draw triangle LMN such that the length of side LM is equal to 3.8 centimeters. The length of side MN is equal to 4.2 centimeters and the length of side NL is equal to 3.2 centimeters. First, let's draw a rough diagram of the required triangle to be constructed. In triangle LMN, the length of side LM is 3.8 centimeters. The length of side MN is 4.2 centimeters. And the length of side NL is 3.2 centimeters. The lengths of the sides must be shown in the rough diagram. Let's start constructing the triangle. Using a scale, draw segment MN of length 4.2 centimeters, with point M as center, and a radius of 3.8 centimeters. Draw an arc on one side of segment MN. Now, with point N as center and a radius of 3.2 centimeters, draw an arc to intersect the first arc. Remember that either of the 2 intersecting arcs can be drawn first. Now, let's name the point of intersection of the arcs point L. Let's join point M and point L. Finally, let's join point L and point N. The required triangle LMN has been constructed.
The triangle LMN is on the upper side of the base MN. With the same measurements, can we draw a triangle on the lower side of the base MN? Let's draw and find this. First, we will draw a rough figure. To draw base MN, draw a segment of 4.2 cm using a scale. Taking M as the center and radius as LM, that is 3.8 cm, draw an arc on the lower side of segment MN. Now, taking N as the center and radius NL, that is 3.2 cm, draw another arc which cuts the previous arc. Let the point of intersection be L. Join LM and LN. The required triangle LMN has been constructed.
Let's practice constructing triangles when the lengths of all three sides of a triangle are given. Draw triangle ABC such that the length of side AB is equal to 3.6 centimeters. The length of side BC is equal to 4.8 centimeters and the length of side CA is equal to 2.4 centimeters. First, let's draw a rough diagram. Now, let's write the lengths of the sides of the triangle in the rough diagram. We have to construct triangle ABC such that the length of side AB is 3.6 centimeters. The length of side BC is 4.8 centimeters. And the length of side CA is 2.4 centimeters. Now, let's start constructing the triangle. Using a scale, draw segment BC of length 4.8 centimeters, with point B as center, and a radius of 3.6 centimeters. Draw an arc on one side of segment BC. Now, with point C as center and a radius of 2.4 centimeters, draw an arc to intersect the first arc. Let's name the point of intersection of the arcs point A. Let's join point B and point A. Finally, let's join point A and point C. The required triangle ABC has been constructed.
Now let us draw another triangle of the same measure on the lower side of side BC. First, draw a rough figure. To draw triangle ABC, first draw segment BC of length 4.8 centimeter. Taking the radius 3.6 centimeter equal to the length of AB in the compass, draw an arc. Now, place the metallic point on C. Draw another arc with radius equal to the length of the side AC, that is 2.4 centimeter. Name the point of intersection as A. Join points B and A Also join points C and A. Thus, we get the required triangle ABC.
Let's construct triangle XYZ. Draw triangle XYZ such that the length of side XY is equal to 4.5 centimeters. The length of side YZ is equal to 5 centimeters. And the length of side ZX is equal to 8 centimeters. First, let's draw a rough diagram. We have to construct triangle XYZ such that length of side XY is 4.5 centimeters. The length of side YZ is 5 centimeters. And the length of side ZX is 8 centimeters. The length of each side of the triangle must be indicated in the rough diagram. Let's start constructing the triangle. As ZX is the longest side, let's draw it as the base of the triangle. Using a scale, draw segment ZX of length 8 centimeters. With point Z as center and a radius of 5 centimeters. Draw an arc on one side of segment ZX. Now, with point X as center and a radius of 4.5 centimeters, draw an arc to intersect the first arc. Now, let's name the point of intersection of the arcs point Y. Let's join point Z and point Y. Finally, let's join point Y and point X. The required triangle XYZ has been constructed.
You know that we can draw another triangle XYZ of the given measures on the other side of ZX. Now think and say, can we draw the triangle of the same measures in a different way? Let's try. Look at this triangle. We will now draw another triangle of the same measure on the other side of the base ZX. But here, we won't draw another segment ZX. But we will make use of the same base ZX of the triangle drawn earlier to draw another triangle. Come on, let us start the construction. Take radius ZY, that is 5 centimeter, in the compass. Now, place the pointed end at point Z. Draw an arc on the lower side of base ZX. Now take radius equal to XY, that is 4.5 centimeter. Place the pointed end at point X and draw another arc intersecting the previous arc. Name the point of intersection as Y dash. Join the points X and Y dash. Also point Z and point Y dash. We get another triangle X, Y dash, Z on the other side of XZ. Now observe both these triangles. Do you remember something? Correct. Point y dash is an image of point y with respect to side zx. Hence, triangle XY' is also an image of triangle XYZ with respect to side ZX. Can we draw similar triangles with respect to side YZ and XY? Let's see. Taking X as the center and radius XZ, draw an arc. Now taking Y as the center and radius YZ, draw another arc intersecting the previous arc. Name the point of intersection as Z dash. Triangle XYZ dash is symmetrical triangle to XYZ with respect to side XY. Similarly, draw symmetrical triangle with respect to side YZ. Good. Triangle X-YZ is symmetrical to triangle XYZ with respect to side YZ.
Now, let's learn how to construct a triangle when the length of two of its sides and the included angle are given. Draw triangle LMN such that the length of side LM is 4 centimeters, the length of side MN is 5 centimeters, and the measure of angle LMN is 45 degrees. First, let's draw a rough diagram of the required triangle. Now, let's write the lengths of the sides of the triangle and the included angle in the rough diagram. In triangle LMN, the length of side LM is 4 centimeters. The length of side MN is 5 centimeters. And the measure of angle LMN is 45 degrees. Angle LMN is the included angle of the side LM and side MN. Let's start constructing the triangle. Using a scale, draw segment MN of length 5 centimeters. Place a protractor at point M on segment MN. And measure angle XMN of 45 degrees. Join point M and point X to get ray MX. Angle XMN measures 45 degrees. Taking point M as center and a radius of 4 centimeters, draw an arc that intersects ray MX at point L. Join point L and point N. The required triangle LMN has been constructed.
The triangle which we have drawn is on the upper side of base MN. We know that another triangle can be drawn on the other side of base MN. To draw this triangle, we will first draw ray MX, measuring 45 degrees on the lower side of base MN. Let's draw a rough figure depicting the given information. Now draw segment MN of length 5 cm. Place a protractor at point M on segment MN as shown here. Mark a point on 45-degree mark. Name this point as X. Draw ray MX. Take radius LM, that is 4 cm in the compass, and draw an arc on ray MX. Name this point as L. Join points L and N. The required triangle LMN has been constructed.
Let's practice what we have just learnt. Draw triangle DEF such that the length of side DE is 6 centimeters. The length of side EF is 4 centimeters and the measure of angle DEF is 120 degrees. First, let's draw a rough diagram of the required triangle. Now, let's write the lengths of the sides of the triangle and the included angle in the rough diagram. We have to construct triangle DEF such that length of side DE is 6 centimeters. The length of side EF is 4 centimeters and angle DEF measures 120 degrees. Let's start constructing the triangle. Using a scale, draw segment EF of length 4 centimeters. Place a protractor at point E on segment EF to measure angle DEF 120 degrees. Mark point X at 120 degrees to indicate the measure of the angle. Join point E and point X to get ray EX. Angle XEF measures 120 degrees. With point E as center and 6 centimeters as radius. Draw an arc intersecting ray EX at point D. Join point D and point F. The required triangle DEF has been constructed.
We know that ray EX can be drawn on the other side of line EF. Let us draw a rough figure first, depicting the given information as shown here. Now we will construct triangle DEF accordingly. First of all, draw a segment EF of 4 cm. Place a protractor at point E on segment EF to measure 120 degree and draw ray EX. With point E as center and 6 cm as radius, draw an arc intersecting ray EX at point D. Join point D and point F. The required triangle DEF has been constructed on the other side of segment EF.
Let's construct triangle UVW. Draw triangle UVW such that the length of side UV is 7 centimeters. The length of side VW is 7 centimeters and the measure of included angle UVW is 75 degrees. First, let's draw a rough diagram of the required triangle. Now, let's write the lengths of the sides of the triangle and the included angle in the rough diagram. We have to construct triangle UVW such that the length of side UV is 7 centimeters. The length of side VW is also 7 centimeters. And included angle UVW measures 75 degrees. Let's start constructing the triangle. Using a scale, draw segment VW of length 7 centimeters. Place a protractor at point V on segment VW to measure angle UVW 75 degrees. Mark point X at 75 degrees. Join point V and point X to get ray VX. The measure of angle XVW is 75 degrees. Taking point V as center and a radius of 7 centimeters, draw an arc that intersects ray VX at point U. Join point U and point W. The required triangle UVW has been constructed.
Now, draw triangle UVW on the other side of VW. First, let's draw a rough diagram of the required triangle. Now, let's write the lengths of the sides of the triangle and the included angle in the rough diagram. The rough figure is as shown here. Now construct triangle XYZ as per the rough figure drawn. Good. Let me see how you have constructed it. First, you have drawn segment VW of the given measure. Then, placing the protractor at point V on segment VW, you have drawn ray VX measuring angle of 75 degree. Taking point V as center and a radius of 7 centimeter, you have drawn an arc that intersects ray VX at point U. Then you have joined points U and W. Thus, the required triangle UVW is obtained.
Construction of triangles. 2 angles and included side are given. Now, let's see how to construct a triangle when 2 angles and the length of the included side are given. Draw triangle LMN such that the length of side MN is 6 centimeters. Angle LMN measures 35 degrees and angle MNL measures 60 degrees. First, let's draw a rough diagram of the required triangle. Now, let's write the measure of the angles and the length of the included side in the rough diagram. In triangle LMN, the measure of angle LMN is 35 degrees. The measure of angle MNL is 60 degrees. And the length of side MN is 6 centimeters. Side MN is the included side of angle LMN and angle MNL. Let's start constructing the triangle. Using a scale, draw segment MN of length 6 centimeters. Place a protractor at point M of segment MN and measure angle XMN as 35 degrees. Mark point X at 35 degrees. Join point M and point X to get ray MX. The measure of angle XMN is 35 degrees. Now, place a protractor at point N of segment MN and measure an angle of 60 degrees. Mark point Y at 60 degrees. Join point N and point Y to get ray NY. Angle MNY measures 60 degrees. The point at which ray MX and ray NY intersect is point L. The required triangle LMN has been constructed.
Now we will draw another triangle similar to triangle LMN on the other side of the base MN. First, let's draw a rough diagram of the required triangle. Now, let's write the measure of the angles and the length of the included side in the rough diagram. To construct this triangle, we will follow the same steps as seen earlier. The only difference is that we will construct it on the other side of the base MN. Let's start the construction. Using a scale, first draw segment MN of length 6 cm. Place a protractor at point M of segment MN and measure angle XMN as 35 degree. Mark point X at 35 degree. Now, place a protractor at point N of segment MN and measure an angle of 60 degree. Mark point Y at 60 degree. Join point N and point Y to get ray NY. The point at which ray MX and ray NY intersect is point L. The required triangle LMN has been constructed.
Let's practice constructing a triangle when two of its angles and the included side are given. Draw triangle PQR such that the length of side QR is equal to 5.6 centimeters. Angle PQR is 30 degrees and angle QRP is 115 degrees. First, let's draw a rough diagram of the required triangle. Now, let's write the measure of the angles and the length of the included side in the rough diagram. We have to construct triangle PQR such that length of side QR is 5.6 centimeters. The measure of angle PQR is 30 degrees. And the measure of angle QRP is 115 degrees. Let's start constructing the triangle. Using a scale, draw segment QR of length 5.6 centimeters. Place a protractor at point Q on segment QR and measure an angle of 30 degrees. Mark point X at 30 degrees. Join point Q and point X to get ray QX. Angle XQR measures 30 degrees. Now, place a protractor at point R on segment QR and measure an angle of 115 degrees. Mark point Y at 115 degrees. Join point R and point Y to get ray RY. Angle QRY measures 115 degrees. Label the point of intersection of ray QX and ray RY intersect point P. The required triangle PQR has been constructed.
Now let us construct triangle PQR on the other side of segment QR. First, let's draw a rough diagram of the required triangle. Now, let's write the measure of the angles and the length of the included side in the rough diagram. Draw segment QR of length 5.6 cm. Draw ray QX in such a way that angle RQX of measure 30 degree is formed on the other side of segment QR. Similarly, draw ray RY such that it forms an angle QRY of measure 115 degree. Name the point of intersection of both these rays as point P. The required triangle PQR has been constructed on the other side of segment QR.
Let's construct triangle ABC. Draw triangle ABC such that the length of side BC is 6 centimeters. Angle ABC is 60 degrees and angle BCA is 60 degrees. First, let's draw a rough diagram of the required triangle. Now, let's write the measures of the angles and the length of the included side in the rough diagram. In triangle ABC, the length of side BC is 6 centimeters. The measure of angle ABC is 60 degrees. And angle BCA is 60 degrees. Let's start constructing the triangle. Using a scale, draw segment BC of length 6 centimeters. Place a protractor at point B of segment BC and measure an angle of 60 degrees. Mark point X at 60 degrees. Join point B and point X to get ray BX. Angle XBC measures 60 degrees. Now, place a protractor at point C on segment BC to measure an angle of 60 degrees. Mark point Y at 60 degrees. Join point C and point Y to get ray CY. angle BCY measures 60 degrees. Label the point of intersection of ray BX and ray CY point A. The required triangle ABC has been constructed.
Now, construct another triangle on the other side of segment BC. First, let's draw a rough diagram of the required triangle depicting the given information. To construct this triangle, which base would you make use of? Correct. First, we will draw segment BC of length 6 cm. Placing the protractor at point B of segment BC, draw ray BX such that it forms an angle of 60 degrees. Now place a protractor at point C on segment BC to measure an angle of 60 degrees and draw rays CY. Name the point of intersection of ray BX and ray CY as point A. Thus, we get the required triangle ABC. Let us do an activity. Now, we will measure the angle A and the lengths of the remaining two sides of triangle ABC constructed. Measure of angle A is 60 degrees. Side AB measures 6 cm. And side AC also measures 6 cm. From this, can you say which type of triangle is it? Correct. Triangle ABC is an equilateral triangle. We have learned how to construct triangles when the lengths of all three sides of a triangle are given. Also, we have learned to construct a triangle when two sides and the included angle are given. We have constructed a triangle when the length of two of its sides and the included angle are given. Now, suppose we have to construct a triangle ABC such that angle A measures 40 degrees, angle C measures 60 degrees, and length of segment AB is 5.5 cm. Can you construct this triangle? First, let's draw a rough diagram of the required triangle depicting the given information. What do you find? Here we have the measures of angle A and C, but the length of the included side is not given. Also, length of side AB is given, but measure of angle B is not given. So what information do we require so as to construct triangle ABC? Right. The length of side AC or measure of angle B is what we need to construct triangle ABC. Recall the properties of the triangles which you have learnt earlier and tell which condition can we find out of the required conditions here. Correct. Using the property of the sum of the angles of a triangle, we can find the measure of the remaining angle, that is, angle B. We know that the sum of the measures of the angles in a triangle is 180 degrees. Thus, angle A plus angle B plus angle C is equal to 180 degrees. Therefore, 40 degrees plus angle B plus 60 degrees is equal to 180 degrees. Therefore, angle B is equal to 180 minus 100, which equals to 80 degrees. Now can you draw the triangle? Good. Now draw another triangle of the same measures on the other side of segment AB. Very good.
Construction of a right-angled triangle. Hypotenuse and one side given. Do you know what the hypotenuse of a right-angled triangle is? The hypotenuse is the side of the triangle that is opposite the right angle. In triangle ABC, angle ABC is a right angle. Therefore, segment AC is the hypotenuse of the triangle ABC. Now, let's construct a right-angled triangle when the hypotenuse and one side are given. Draw a right-angled triangle LMN such that angle LMN measures 90 degrees. The length of the hypotenuse, side NL, is 7 centimeters. And the length of side MN is 5.5 centimeters. Draw a rough diagram of the triangle to be constructed. Now, let's write the measurement of the angle and the lengths of the hypotenuse and one side in the rough diagram. In triangle LMN, the measure of angle LMN is 90 degrees. The length of the hypotenuse NL is 7 centimeters. And the length of side MN is 5.5 centimeters. Let's start constructing triangle LMN. Using a scale, draw segment MN of length 5.5 centimeters. Place a protractor at point M of segment MN to measure an angle of 90 degrees. Mark point X at 90 degrees. Join point M and point X to get ray MX. Angle XMN measures 90 degrees, with point N as center and radius 7 centimeters. Draw an arc to cut ray MX. Name the point of intersection L. Join point L and point N. The required triangle LMN has been constructed.
Do you remember? We can draw another similar triangle on the other side of side MN. Let's construct another similar triangle on the other side of MN. Draw a ray MP on the lower side of MN, making a 90-degree angle with the side MN. Take center N and radius 7 cm. Draw an arc on ray MN. Name this point as L'. Join point N and point L' such that triangle L'-MN is formed. Observe the figure carefully. Which type of angle is angle L'-ML? Yes, it is a straight angle. Can we construct this triangle in any other way? Just try it out.
Now, let's practice what we have just learnt. Draw a right-angled triangle UVW such that angle UVW measures 90 degrees, the hypotenuse, side WU, is equal to 5 centimeters, and side VW is equal to 4 centimeters. First, let's draw a rough diagram of the required triangle. Now, let's write the measure of the angle and the lengths of the hypotenuse and the given side in the rough diagram. We have to construct triangle UVW such that angle UVW is 90 degrees. The length of the hypotenuse, side WU, is 5 centimeters. And the length of side VW is 4 centimeters. Let's start constructing the triangle. Using a scale, draw side VW of length 4 centimeters. Place a protractor at point V on segment VW to measure an angle of 90 degrees. Mark point X at 90 degrees. Join point V and point X to get ray VX. Angle XVW measures 90 degrees, with point W as center and radius 5 centimeters. Draw an arc to cut ray VX at point U. Join point U and point W. The required triangle UVW has been constructed.
You already know that we can construct another similar triangle on the other side of base VW. First, draw a rough figure and construct the required triangle accordingly. Good.
Now, let's construct triangle DEF. First, let's draw a rough diagram of the required triangle. Now, let's write the measure of the angle and the lengths of the hypotenuse and the given side in the rough diagram. In triangle DEF, angle DEF measures 90 degrees. The length of side EF is 8.5 centimeters. And the length of side FD is 10 centimeters. Let's start constructing the triangle. Using a scale, draw segment EF of length 8.5 centimeters. Place a protractor at point E on segment EF. Mark point X at 90 degrees. Join point E and point X to get ray EX. Angle XEF measures 90 degrees. With point F as center and radius 10 centimeters, draw an arc to cut ray EX at point D. Join point D and point F. The required triangle DEF has been constructed.
And this is another triangle DEF on the other side of the base EF. Here, we have seen that triangles can be constructed on either side of the given base. Note that you can construct any one of them. We have now learnt construction of different types of triangles. Here we have an activity. Look at this given information. Based on this information, we have to construct a triangle. In triangle ABC, measure of angle A is 75 degree, measure of angle B is 115 degree, and length of AB is 5 centimeter. First, let us draw a rough figure. Angle A measures 75 degree, and so it's an acute angle. And angle B measures 115 degree, so it's an obtuse angle. Let's start constructing the triangle. Using a scale, draw segment AB of length 5 centimeter. Place a protractor at point A. Draw ray AD forming an angle of 75 degree. Now, place the protractor at point B. Draw ray BE forming an angle of 115 degree with segment AB. In which point do these rays intersect? Oh, these two rays do not intersect each other. Can we construct this triangle? No. Now think over it and find out the reason. Correct. On observing the measures of the angles, you will realize that the sum of the measures of both the angles is 75 plus 115, which equals 190 degree. According to the property of triangles related to its angles, the sum of the measures of the angles of a triangle is 180 degree. The sum of two angles here is 190 degree, which is greater than 180 degree. Thus, we cannot construct this triangle. Now, have a look at this given information. In triangle PQR, length of side QR is 2 cm. Length of side PQ is 4 cm. And that of side PR is 2 cm. Can we construct this triangle? Come on, let's try to construct it. First, let us draw a rough figure. Now we will construct the triangle accordingly. Draw segment PQ of length 4 cm. Take center P and radius 2 cm. Draw an arc on one side of PQ. Now, taking Q as the center and radius 2 cm, draw another arc and the point of intersection would be R. But what do we see here? These two arcs do not intersect each other, which means we cannot construct this triangle. Can you tell the reason for this? Correct. Let's recall the property of the triangle related to its sides. Right. The sum of the lengths of the two sides of a triangle is greater than the third side. Here, the sum of the sides PQ and QR is 4 plus 2, which equals 6 cm. Hence, this sum is greater than the third side measuring 2 cm. Now find the sum of the sides QR and PR. This sum is 2 plus 2, that is equal to 4. But this is equal to the third side, which is equal to 4 cm. Hence, we cannot construct triangle PQR. Remember, we can decide if a triangle can be constructed or not by observing the measures of the sides and angles of the triangle. For this, we must know the properties of the triangle. These properties are: 1. The sum of the measures of all the three angles of a triangle is 180 degree. 2. The sum of the lengths of any two sides of a triangle is greater than the third side. Let's do one more activity. Draw triangle ABC such that BC is 8 cm, CA is 6 cm, and angle ABC is 40 degree. As always, let's first draw a rough diagram of the required triangle and write the given measures. To construct the triangle, we will draw a segment BC of length 8 cm. Angle ABC measures 40 degree. So, place the protractor at point B, mark a point at 40 degree, and draw ray BX. Now, take radius equal to length AC, that is 6 cm in the compass. Place the metallic point at point C and draw an arc intersecting ray BX. In how many points does the arc intersect ray BX? In 2 points. Name one of the point of intersection as A and the other as A'. Join points A and C, also points A' and C. We get two triangles here, triangle ABC and triangle A'-BC. In both these triangles, length of side BC is 8 cm, angle ABC measures 40 degree, and length of side AC is 6 cm. Here you will find that we get two different triangles of the given measures. Now let us do one more activity. If we are given the measures of all the angles of a triangle and no side is given, can we construct this triangle? If yes, then how many such triangles can be constructed? Let's construct triangle PQR such that angle P measures 45 degree, angle Q measures 60 degree, and angle R measures 75 degree. Here we are not given the length of any side. Let's construct triangle PQR taking length of side QR as 5 cm. The measure of angle P in triangle PQR so constructed is 45 degree. Measure angle Q is 60 degree and measure angle R is 75 degree. Now, construct this triangle taking QR 8 cm and with the same measures of the angles. Observe both these triangles. What do you find? They are of equal shape having different sizes. This means that if the measures of all the three angles of a triangle are given, we can construct infinitely many triangles of the same shape having different sizes.